See this problem. In a series LCR circuit, R is equal to 200 ohms and the voltage frequency of mains supply is 200 volts and 50 hertz respectively. On taking out the capacitance from the circuit, the current lags behind the voltage by 45 degrees. On taking out the inductor from the circuit, the current leads by the voltage 45 degrees. Calculate the power dissipated in the circuit. So our motto is, there is an LCR circuit connected with some AC sources. So the specifications of these AC source and LCR circuit is given. So the condition is when you are look at this, the condition is on taking out the capacitance from the circuit, that means remove the capacitance and connect directly the inductor and the resistor. So at that moment, for a LR circuit, the lagging angle is phi is equal to 45 degrees. And next what we have to do, remove inductor and connect capacitor with the resistor. That will become CR circuit. At that moment, phi leads by 45 degrees. The phase difference, phi leads by mean the phase difference is phi is equal to 45 degrees is the phase difference. So that is happening when you are connecting one after other. These two are the conditions given in it. So we need to find out the power dissipated. So when the current is flowing in through the circuit, you need to find out the power dissipated in the LCR circuit. That means for the whole combination we need to find out P. We can find power directly, but depending upon the conditions we need to find the power dissipation. So what are the conditions? These are the conditions. We don't know L, we don't know C. So with that we need to find out, we don't know I even. So with that we need to find out the power dissipation. Generally, in general expression for in resonant frequency, the power dissipation P is equal to V square, Vrms square by R. We can't implement this formula directly here because there is no resonant condition. So for that type of problems we have some other formula for the average power dissipation. So the thing is, our motto is to find average power for the LCR circuit that dissipated by connecting L, C, R in a series combination. That is our motto. Now I am moving to investigate what type of quantities that I have given. So R resistance is given, that is 200 ohms, and RMS voltage is given, that is 200 volts, and its frequency F is given, F is equal to 50 hertz, and phase angle phi is equal to given at different combinations, but that is same, so I am writing phi is equal to 45. Now I am going to resolve the problem. While resolving, I am writing the average power formula when the resonant condition is not given. So at that moment P average is equal to Vrms into Irms into cos phi. That is the condition for the average power dissipation in a LCR circuit when the resonant condition is not given. But Irms is, we already know Irms is equal to Vrms by R, because I is not given. For the I we need to search for similar expression, that is Irms is equal to Vrms divided by R into cos phi. Our total is Vrms square by R into cos phi. Here we got an expression for P average in terms of Vrms, R and cos phi. Now I'll write an expression for the phase difference. So I'm writing phase diagram or phase graph, so in which the phase angle represented as phi, on the side is R and opposite side is XC minus XL. So because of capacitor and inductor, we are getting some inductive capacitance, inductive reactance, so inductance. So with these two I'll get a final impedance Z. So here tan phi, when in an LCR circuit, tan phi is equal to XC minus XL by R. That is the formula that we know for a phase, to find the phase angle for the LCR circuit when they are not in resonant condition. From the same problem, cos phi is equal to R by Z. So these two are the expressions for the phase angle. Now I am going to resolve these two expressions for LR and CR circuits. LR and CR circuit, because you are removing one after other. So for LR circuit, tan phi is equal to XL by R, because XC is 0, you are removing the capacitor. So XL by R. What is phi angle? If you are removing capacitor, what is the lagging phase? It is 45 degrees. That is given in the problem. Tan 45 is equal to XL by R. So from this, tan 45 is 1. So from this it is XL is equal to R. Now come to CR. In CR, tan phi is equal to XC by R. So here also it is leading 45 degrees ahead. So he taught tan 45 is equal to XC by R. So with this I'll get XC is equal to R. So when you are taking the phase angle individually, at that moment whatever the inductive reactance, whatever the inductive capacitance you are finding, that is equal to the resistance that you have connected in the circuit. So name it as 1 and 2. Now I am going to find the P average of the circuit, total circuit. P average is equal to, we have V square RMS square by Z. We need to write Z. ZY, it is LCR circuit, and the total impedance expression we need to write here. That is the exact expression. So here I am writing, I have written R, right? So R into cos phi. What is cos phi? From the expression R by Z. So that is equal to V RMS square by R into R by Z. So RR gets cancelled. I'll get V square VRMS square by Z. So that is the final expression for P average for an LCR circuit. The same thing I have written here also. What is Z? VRMS square by root of R square plus XC minus XL whole square. That is the expression for the total impedance of the circuit, LCR circuit. That is equal to VRMS square divided by root of R square plus, here XL is same as XC, so R minus R whole square. So this gets cancelled. So the remaining thing for us is VRMS square by R. So from this, what is VRMS? 200 into 200 divided by R is 200. So that is equal to 200 watts.